Hello, Cloud Gurus. It's time to deploy your first application into Kubernetes. That's right. We're going to start an application, get it up and running inside Kubernetes, all in this lesson. And by the end, you'll see just how easy this is to do. To do this, we'll start off by creating a deployment called Web1. And inside that deployment will be a pod. And in that pod will be the Nginx web server, which is a very popular open source web server if you're not familiar with it. We're going to use an image called Nginx demos/hello, which is essentially a demo image for the Nginx web server that's going to show us the name of the container that web server is running inside. So just remember, as we talked about earlier, in Kubernetes you create deployments, inside deployments are pods, and inside pods are containers. And those containers run our company's applications. From there, we'll scale up the deployment. Why? Because we can. Kubernetes makes it super easy. With this single command, we'll go from having one web server running in a single pod in the deployment to suddenly having 20 web servers running in that deployment. Normally, it would be very difficult to scale up to 20 web servers or even 200 or 2,000 web servers. But Kubernetes makes this easy to do with a single command. This is exciting stuff. After that, we'll expose the deployment to the network. And this is a little bit more of an advanced topic since we haven't gone much into networking at this point. But the purpose of exposing the web server deployment and creating a load balancer is to allow us to test these 20 web servers. From there, since we're running Kubernetes in Minikube, we need to run the Minikube service web1 command, which is the name of our deployment. This will give us the URL that we can use to access our load balancer for the entire web server farm so that we can test our web servers, and I can prove to you how successful this really is. So with that, let's jump over into the lab environment, and I encourage you to follow along. What we'll do to run our first application in Kubernetes is to run kubectl create deployment, and we'll use the image nginx demos/hello space web1. Web1 is going to be the name of the deployment, and while we could just run the Nginx web server by itself, I really like the Nginx demos/hello image because it's going to give us information about the container that the web server is running inside. With that one command, we've deployed our first application on Kubernetes. It tells us that our deployment, web1, was created. If we type kubectl get deployments, you can see we have one deployment up and running called web1, and all of the pods in that deployment, 1 out of 1 at this point, are up and running in a ready state. If we type kubectl get pods, you can see we have one pod running. It is in a ready state, and its name is web1 with an automatically appended GUID string. So now what if we wanted to scale this up from just a single pod or a single web server running in our deployment to 20 pods or 20 web servers running in this deployment? If we do a kubectl get pods -w to watch, you can see that these 20 pods are being created, and very quickly, they're all up and running. If we do a Control-C, let's clear the screen, and let's do kubectl get pods, and you can see we now have 20 web servers all up and running. That's how easy it is to massively scale applications with Kubernetes. If we do kubectl get deployments, you can see we have 20 pods that make up this deployment, and 20 out of 20 are in a running state. So now if we wanted to test our web servers, we need to first expose those web servers by creating a service. This is going to allow us to access these web servers from a web browser on the network. By default, one group of containers doesn't really know how to reach another group of containers because IP addresses are constantly changing. And for that reason, we need to expose the deployment. We'll expose these on port 80, and we'll configure the type to be a load balancer. And by the way, it is case sensitive, capital L, capital B. And you should know that there are a number of different service types that you can create, with load balancer just being one of them. A load balancer service type assumes you have some sort of external load balancer, such as a load balancer in the public cloud. So that created our service called Web1. If we type kubectl get service, there you can see we have the Web1 load balancer created. And if you're wondering why the status of the load balancer is pending, that's because, as I mentioned, we're pointing to a cloud-based load balancer that actually isn't up. But that's not going to affect the test that we're doing in this lesson. And now, because we're using Minikube, we need to use the Minikube service command with the name of the service. This will automatically open up our web browser and point it to the URL of the load balancer. And that's simply because Kubernetes is running inside the Minikube virtual machine. So if we press enter on this, it brings up our web browser, and take a look at that. We have the Nginx web server up and running. The server name is actually the name of the container. That's going to correspond to a container. If we click auto refresh on this, periodically, this will be automatically refreshed, and you will probably see the name of the container change. However, if we add more load, we'll probably see the name of these containers change much faster. So let's get a few of these up and running. There, we can see all 4 web browsers that are up and running. They're all hitting the Kubernetes load balancer, and they're all accessing this web server farm. And there you go. Did you see that one just changed? And now all of them changed. So essentially, we're doing round robin, going across all the different containers that make up this Kubernetes deployment, which is being accessed by the exposed service on port 80. And periodically, you'll see the name of the containers change to a new container. There we go. There's another change again. And this is how our load is automatically being distributed to this Kubernetes web server farm. And that's how easy it is to get your first application up and running in Kubernetes. And we didn't just choose a super simple application either. We created a deployment with 20 web server pods. We exposed that deployment by creating a service on port 80. And finally, we tested the web server farm to make sure we could access these web servers via the load balancer. I hope you'll stick with me and join me in the next lesson, where we'll be bringing up more applications in Kubernetes.